Hi my friends, the transformer deep learning architecture has taken the AI world by storm. It is the basis of ChatGPT as well as many large language model applications. The architecture is based on the paper "Attention is all you need." It is a very complex architecture and very geeky to understand. However, I will demonstrate this revolutionary architecture visually with very simple example. The visual demo which I'll show you is also available on my platform experienceddatascience.com, and you can also try it out. No coding skills are required. So my friends, let's get started, but do not forget to subscribe to the channel, like and comment on the video. Broadly speaking, ChatGPT is a next word prediction application, but of course its capabilities extend beyond that. Given a sentence such as "what is a transformer," it tries to predict the words which can come after the question. And these predicted words form the ChatGPT response. In this demo, I'll be taking an example of predicting the next letters in an English alphabet. It's a very simple example, but will help you clearly understand the complex architecture. The transformer has got two main components, the encoder on the left and the decoder on the right. In this demo, we will focus only on the encoder part. Let us first start with the data input. The data is a list of alphabets. We first break them into blocks based on the block size. For example, a block size of 3, each input will correspond to 3 characters. This means that we'll be using maximum of 3 characters to predict the next character. The block size is also called the context length. Then we break the blocks into batches, and this is done for performance reason. For example, a batch size of 2, there will be 2 records in a batch which will be used to train the model. Each batch is then used to create training data. For example, if the input is A, then the target is B. If the input is AB, then the target is C, and so on and so on. So each batch can have multiple training examples. Now let us move to the next architecture component, which is the input embedding. It converts input alphabets into numeric vectors. I've chosen the vector to be 8 dimensions, and one way of visualizing the vectors is using a heat map. On the y-axis you have the alphabet, and on the x-axis you have the 8 dimensions. You can observe from the heat map that no 2 alphabets have got similar values, so each alphabet is a unique vector. We can also reduce the 8 dimensions into 2 dimensions using various dimensionality reduction techniques, and also plot all the vectors as a 2D scatter plot, where each alphabet here is shown as a dot. Now, one interesting observation you can make with this scatter plot is that usually the consecutive alphabets are close to each other. For example, A and B are close to each other. Another example, on this side of the visual, we can see that R, S and U are close to each other. Now, let's go to the next component, which is the positional encoding. In large language model, the position of the word matters, even though a word can have similar embedding vector but can have different positions. The position can be encoded with positional embedding. It takes the output of embedding, which has got 8 dimensions in our example, and then based on the position adds some value. The value for each dimension is generated using sine and cosine functions of varying frequency. And it's for this reason you see the heat map has got an alternating pattern. Now this logic ensures that the value of positional encoding is unique for each position. Now let's go to the next component, which is the multi-head attention. Attention is a mechanism which helps the model to learn about the relation between different words. The attention value can be visualized using a heat map. Both x and y axis of the heat map are alphabets, and here I'm showing 3 alphabets as an example. the color shows how much attention each alphabet pays to another alphabet. For example, the letter A pays most of the attention to itself. The letter B pays most of the attention to itself but also to the letter A. And the letter C pays most of the attention to itself. Now, determining the relation between each word is one of the most important part of the transformer architecture. Now, let us go to the next and the last component of the encoder called the feed forward. This component takes all the previous inputs and makes the prediction. So, for example, if our input sequence is A, B, C, then it would predict D, E, F. The output of the feed forward can be visualized using this heat map. The x-axis corresponds to the first, second, and the third prediction. The y-axis is all the letters. Highest value of the heat map corresponds to the predicted letter. So for a given sequence A, B, C, let us filter on the highest value. And here we see that the output sequence predicted corresponds to D, E, and F. So let me summarize what you have seen till now. The input embedding layer helps converting text into numeric representation. The positional encoding layer gives a positional representation for each input. Multi-headed attention helps in determining the relation between different words. Feed-forward layer does the final thinking and makes the prediction of the next words in the sequence. Now here is a simple sentence which summarizes the transformer architecture. It takes the input sequence, makes a numeric representation, determines a positional representation of each input, establishes the relation between inputs, and then does the final thinking to predict the output sequence. Now let me show you on how you can access all the visuals which I have shown you, as well as execute all the analytics which were shown in the video. So you can go to my platform experiencedatascience.com. The link is in the description, and then you can go ahead and select the Experience Transformer Alphabet Generator. Once you are in the experience, you can always hover over the tip button to see what needs to be done at each step. I've set up two data sets, one for model training, one for model scoring, and you can select both of them one by one and copy it to your data. Once the data has been copied, you can go ahead and select the data set. And then here you will see three tabs. You will see the data display tab, a second tab which is related to the transformer model training, and third is which will generate the text. You can then go into the data display and then go ahead and select the parameters which I have indicated in the tip. So for example, in this particular case, you will be able to display the data which is available in the training data set. And once you execute it and finish it, you will be able to see the data. You can do a similar exercises for the training the transformer as well as for the third step which is required to generate the text. I will leave it to you as a call to action to do all the analytics and get all the visuals which I have shown you. But just to show you what results you might get, you'll get a loss curve for the model training, and then you'll get the outputs which are generated while generating the text. You will see different URLs which is related to the embedding scatter plots as well as attention plots, and you can take all these URLs and you will see the same visuals which I have shown you in the video. So thanks a lot for watching, and hopefully you can try out these exercises on experiencedatascience.com, and see you soon in the next video.